the sign for the imaginary part. Okay, and then you also have a theorem. Okay, so you have a theorem, all right, in which you have a theorem for product of conjugate pairs. Okay, so you have a conjugate pairs, a product of conjugate pairs, a plus bi times a minus bi. So you have a formula which is equals to a squared plus b squared. Okay, so if you want to use, all right, if you want to use this formula, okay, then you got to memorize, or else you got to expand, because basically whenever we have a product, okay, of two complex number, we are going to expand anyway. Okay, all right. That is a product of what we call conjugate pairs. And another thing about multiplying by conjugates or a product of conjugate pairs, your product is actually is a real number, and that real number is a positive real number, or we call it non-negative real number. Okay, so when you have a product of two conjugate pairs, you will not get complex number, but you will get only a real number. Okay, so hence, because of that, okay, then only when it comes to a quotient, okay, a quotient expression, or what we call like a reciprocal expression, or even later on division of two complex numbers, okay, division of two complex number, okay, you will see that, all right, in order for us to divide, all right, we need to actually multiply by what we call conjugate of the denominator. Okay, because often, all right, when you are given questions whereby they give you in terms of a quotient expression, okay, or they give you like a division question, divide two complex number. So what you need to do, all right, you need to multiply by conjugate of the denominator, so that at the end of the day, all right, your answer can be written as a standard form of a plus bi. Okay, so again, the reason why we multiply by the conjugate of the denominator expression is because, all right, just now we mentioned that when we multiply two conjugate pairs, what we'll get is actually a positive number or a real number. We don't get complex number, but rather we get just a real number. Okay, so then only we can actually write in terms of our standard form of a plus bi. Okay, so that is why we multiply by conjugate pairs. Okay, when it comes to division, okay, division of two complex number. Okay, and then you have also properties. Okay, you also have properties. Okay, Nabila, can you? Okay, all right. All right. Okay, you have also properties. Okay, if you look at the properties, like you have as, okay, bar, z bar notation is actually is a conjugate. Okay, conjugate. It's a conjugate expression. So z bar means it's a conjugate. Okay, conjugate of that particular z. Okay, so if you look at properties, z bar with the bar, z bar, and then you bar again equals to z. Okay, now if you want to make sense of all these properties, okay, what you need to do, you just come up with an example. Okay, for example, all right, if you have like z bar, if let's say you are given let's say you have z equals to, let's say 3 plus 5i. Okay, let's say z equals 3 plus 5i, and then z bar equals to 3 minus 5i. So the difference will be the sign, all right, the sign of the imaginary part. Okay, Muhammad Hakim, can you unmute your mic? Okay, and then if with the z bar, you bar it again one more time. Okay, so you get 3 plus 5i. So this is where this is the same as your z. Okay, so this is where you have this first property here. Okay, so the next properties is saying that, you know, conjugate of a sum of two complex number is the same as addition of two conjugates of that complex number. Nur Adlina. Okay. All right. Somehow, okay, hold on. Okay. All right, all of you, what do you see on your screen?
Nothing, madam.
It's nothing, madam.
Nothing, madam.
Nothing.
Is it my slide? Do you see my slide screen?
Madam, I can see.
No, madam.
Madam.
Can you talk louder? Somehow I cannot hear you.
I cannot see, madam.
I cannot
We
see
cannot
your
see your
screen.
Oh, you cannot screen, eh? That's right.
Yeah.
This I think something happened. Okay, let me just try to share again the screen. Okay, let me just try one more time. Hold on, eh? Okay, can you all see now?
Yes, madam.
Yes, madam.
Okay. All right. Okay. All right. So just now I was mentioning about these properties. Okay, these properties. Conjugate of a sum is equals to sum of two conjugates. This is what it means. Okay. Similarly, okay, conjugate of a product is the same as a product of two conjugates. Okay, so to make sense of these two properties, you can just again, as I mentioned just now, just come up with any two complex number, so you can see, all right, left hand side equals to right hand side. Okay, so this is how you make sense of this property. Okay, any questions so far?
Madam.
Yes.
I'm so confused with a line
With what, Mia?
in Z. What it's mean?
What does it mean by what?
The line, the minus sign in Z.
Oh, you mean the bar, the sign with the bar. This
Yeah,
is it?
above Z. Yeah.
Okay, the bar sign is actually represent conjugate sign. For example, okay, this is the given Z. Okay, this is the given Z. All right. So Z bar. All right, this is actually conjugate. Okay, Mia?
Okay.
Okay, Z bar is just to represent conjugate.
Okay,
Okay,
understand,
so
madam.
Z bar is just a notation for conjugate. Z bar is just a notation for conjugate. All
Okay,
right.
madam.
Okay. All right. Okay. So perhaps today what I'm going you all to do is we will start by just yes.
Madam, I think Muhammad Hakim forgot to mute his Webex.
Update dulu
Yeah. Hakim. Hakim. Hakim, can you mute your mic? Okay. All right. Okay. So perhaps we'll start by looking at a question. Maybe I would like you to try this question. Okay. Let's look at this example. Okay, let's say you are given two complex number. Let's say Z1 equals to minus 2 plus 3i and Z2 equals to 1 minus 4i. Okay, so you have to find, okay, so Z1 plus 2, Z2, and then B is Z2 minus I times Z1, and then C Z1 times Z2, and then D Okay, D Z1 divided by Z. Can you all try? Perhaps I'll give you maybe like 5 minutes and then we'll discuss the answer. Okay, so 5 minutes. So try this. Okay, has everyone finished? Are you all done?
Not yet, madam. Almost.
Okay, all right. Okay, another few more minutes. Okay, please try, everyone, all of you, please try the questions. Okay, has everyone done? Have you all finished?
Yes, madam.
All right, okay. Anybody would like to give me the answer for A? What's the answer for A?
Negative 5i.
Negative 5i, madam.
Negative?
5i.
Okay,
Negative
negative
5i.
5i for A.
Madam, you have muted yourself, madam.
Can you all hear me?
Yes, madam.
Yes, madam.
Yes, madam.
Can you hear me? Okay, all right, okay. All right, okay, what's the answer for B?
It is 4 minus 2i.
Okay, 4 minus 2i. Anybody got different answer? Everybody got this one, 4 minus 2i? All right, okay. What about C? What about C?
I got 10 plus 11i.
Okay, Norafika. Okay,
10
say again.
plus 11.
All right, okay, Norafika. Yes,
Yes,
10.
madam. 10 plus 11i.
Okay. Okay, all right. So that's C. All right. What about D? Anybody? D? Anybody else? Would like to give me the answer for D?
14 per 15.
Say again. Say again.
I'm not sure this answer. 14 per 15
14 over 15.
minus 5 over 15i.
Minus 5 over 15 I. Anybody else got any different answer?
Me.
Me.
Okay, what do you get? Ikhwan, is it? Ikhwan Haziq,
10 plus
you want to say something?
10 plus 11i over 17.
Let's see. Oh, 10 plus 11i over 17. Okay.
Yep.
Okay, any more? Any more different answer?
10 plus 10 minus
Anybody
5i
else got
over
different answer?
17.
Say again, Ukasha.
10 minus 5i over 17.
10 minus 5i over 17. Okay. Any more? Any other different answer?
Negative 14 over 17.
Negative 14 over 17.
Minus
Okay.
minus 5 over
Okay.
17 I.
Okay. All right. Thank you, Sharice. Okay. Any more? Any other different answer? Okay. All right. So which one is the right answer? This is actually the right answer. Okay. That's the right answer. 14 over 17, 5 over 17i. Okay, so let's do this for D. Okay, this is your Z1 over Z2, which is your, okay, Z1 is minus 2 plus 3i divided by 1 minus 4i. So what we are saying is that we need to multiply by conjugate of the denominator for both numerator and denominator. Okay, so then when you multiply by the conjugate, okay, when you multiply by the conjugate, your denominator, okay, your denominator, you can just use your a squared plus b squared. So your a squared is 1 squared plus b squared is your 4 squared. Whereas the numerator, you got to expand one by one. You expand that. So minus 2 times 1. So minus 2. And then minus 2 times 4i. So minus 8i. And then 3i times 1. So plus 3i. And then finally, you have your 3i times 4i. So that is your 12i square. Okay. All right. And then don't forget that you have your I square here. That is minus 1. Okay. So then you simplify. All right. So you will have your minus 2 minus 12. So that is minus 14. So minus 8 plus 3. So you have your minus 5i over 1 squared plus 4 squared, that is 17. And if you leave your answer like this, all right, you will lose one final mark for the last answer, because final answer you must always write in terms of standard form of a plus bi. So you must write in terms of minus 14 over 17 minus 5 over 17i. Okay. All right, okay, everyone? Understood? Any questions?
Understand, madam.
Yes.
Understand, madam.
Can you
Okay.
minimize the screen a bit? I want to screenshot the answer.
All right, okay.
I want to ask about
Oh, this one. This one is it?
body, madam.
Okay. Okay. You wanna ask which one? Dorafika, you got a question?
Nak tanya yang ni tu madam.
Okay.
Kalau macam madam yang siap
Which one?
one square plus one square. Saya buat satu tolak empat kan. So yang bawah madam yang first one square atas saya buat satu I dah satu I kan.
Which one?
Yes.
This one, you make here.
Yes.
Multiply by what?
Yang bawah ni pun. Yang one square plus one square tu.
This one. This one?
Kalau yang buat satu lah, I dah satu buat I sama kan.
Yes.
Yes. Yes. Alright.
This can cancel, and I squared equals 1 minus 1. So you have that what is 16. So what is 16 plus 1. So your 7. Okay? Okay. Alright. Okay, any more questions? Before I proceed, any more questions? Alright, okay. Okay, so if there's no more questions, then we will proceed to the next one. Okay, so now we come to the next section, which is what we call polar coordinates. Alright. Okay. So this is essentially I don't know whether it's a new topic. Perhaps some of you or perhaps all of you have actually come across with polar coordinates. Perhaps you just have forgotten, or if this is your first time looking at this, okay, so you might want to give it attention, okay. So polar coordinates is one special topic in which later we will see that we are going to deal complex numbers in polar coordinates. So that's why we have one topic, right, in our chapter 4, which is introduce you what we call polar coordinates. Okay, polar coordinates is just another coordinate system besides rectangular. Okay, rectangular coordinates. Okay, rectangular coordinates. Rectangular coordinates can also be called as your xy coordinates. Okay, or you can call it as xy plane usually. Or you have your Cartesian coordinate system. Okay. Cartesian coordinate system. That is our rectangular. Okay. So basically, whether we call it rectangular coordinate or Cartesian coordinate system or xy coordinate system or xy plane, those are the same thing. we are talking about the same thing, which is our this type of axis. So you have your x and y. Okay, remember this? Okay, so this is your x, y axis. Okay, when we talk about the diagram of our Cartesian coordinate system, our rectangular coordinate system, we are talking about this type of x, y axis coordinate. Okay, and for this rectangular coordinate system, okay, if you remember, previously you are familiar with the graph paper. Graph paper is actually some sort of a rectangular coordinate. Why it is called rectangular? Okay, because rectangular means you remember your graph paper. Okay, your graph paper is actually is with this type of grid. Remember, you have the grid like this. Okay. Okay, that's why it is called rectangular coordinate, because it looks like this is a rectangular shape. Okay, all these are rectangular shape. Okay, so you have that. Yes, that's why it is called rectangular coordinate system. And for this rectangular coordinate system, previously, you remember the middle here, the center. Okay, is what we call the origin. This is called the origin. The center is called the origin. This is our axis. This is also our axis. So we have our x and y axis. This is what we call it. Okay? And this side is what we call positive x. Okay? Positive x axis. Alright? Which contains positive number. Right? We call it negative x axis because this is where you have a negative number here. Because the origin is a zero. The number is zero at the origin. Okay, this 0 for x, 0 for y. That is called our rectangular coordinate system. And going up, you know that is a positive y. Going down, so our negative y. Okay, and we talk about a coordinate number, a coordinate itself. Okay, a coordinate is let's say this is minus 2, 3. Okay, minus 2, 3. Alright. So we ask you to plot. Okay, this coordinate minus 2, 3. Definitely you are going from the center. Okay, go 2 units left. And then 3 units up. 1, 2, 3. So that means, alright, the location is here. Okay. So you go 2 units left from the origin and then go up units. So this is the location of coordinate minus 2, 3. And this coordinate location here, alright, the location here, that location represents this coordinate. So in other words, like this location is this is the address. Okay, this is the address for this location. And there is no other coordinate for this particular location. This particular location will have only one and one coordinate, which is minus 2, 3. And that's all. Okay, so that is our rectangular coordinate system. Okay. When it comes to polar, for polar coordinate system, it is actually a different type of coordinate system. And polar coordinate, we look at the table here, alright? We have a center, what we call pole, and then our positive horizontal line, another positive axis here, we call it polar axis. And if you look at this, alright, this coordinate is in terms of r and theta. Okay, theta is you understand. Theta represents angle. Okay, so that means this polar coordinate is actually deals with angle. Okay, so let me just show you what we call polar grid. So polar coordinate of this is what we call polar grid. Okay, the grid for rectangular is like this. Okay, the grid for rectangular is like this. Right? This is of rectangular shapes. Polar grid looks like this. Okay, polar grid. The next polar grid is right, and polar grid GRID. Okay, so polar grid. This is what we call polar grid. Polar grid, you look at it in terms of like a circle. So you have many circles. Okay, you have many circles within circles like that. Okay, alright. The center here, the center in the middle. Alright, this is what we call the pole. This is the center for the polar grid. So the center is what we call pole. Okay, we call it pole. P-O-L-E. That is the center of the polar grid. Right? Polar grid. And this is going this way. Right? Going this way. That is what we call polar axis. Okay, so this one, this is what we call polar axis. Okay, so that is polar axis. So that means polar axis, if you compare, alright, with your rectangular grid, pole is the same as the origin. Polar axis is the same as positive x-axis. Okay, positive x-axis. That is what we call polar axis. Okay, and then this circle here, all this circle, this actually represent distance. Okay, distance from the pole. That is r. Distance from the pole. That means this is assuming this is your one circle. So this actually has a distance of 1 unit. This is a distance of 2 units from the pole. This is a distance of 3 units from the pole. This is the distance of 4 units from the pole, 5 units from the pole, etc. Okay, so distance can be many. All right, not only we stop at 5, it can be 6, 7, 8, 9, 10, etc. Like our rectangular grid also. Okay, our rectangular grid also, it can. Our rectangular grid also, it can goes on and on, right? Okay, so it can goes on and on. It doesn't stop here. Okay, it's not like just 1, 2, 3, 4, 5. So it can goes on 6, 7, 8, 9, etc. Okay, so similar. So back to polar grid. All right. So the circle represent distance from the pole. So which means, all right, this circle here is a 1 unit distance from the pole. This is 2 unit distance from the pole. The third circle represent 3 units from the pole. Okay, so 3 units from the pole. So it goes like a circle, a circle. Okay, and then you have what we call here angle. This is angle. So that means you have theta. Theta represent angle. So you have angle. Okay, so in terms of coordinate, it is represented by what we call r theta. Okay, r theta. So for polar coordinate, it is represented by okay, what happened here? Someone is trying to share, is it? Oh, okay. All right. Can you all see my what's on your screen?
It's nothing, madam.
Huh?
It's nothing.
Nothing. Can see anything.
Oh, okay. Okay. All right. I think like just now someone like okay. Okay, let me just share again. Because just now it looks like someone is trying to share something on the screen. Okay, can you all see now?
Yes, madam.
Yes, madam.
Okay, all right, okay. So back to polar coordinate, it is represented by r theta, okay, in which r, okay, in which this r here, this r is actually is a distance from the pole, okay, all right, that is a distance from the pole to the point, okay, from the pole to the point. Okay, to the point. Whereas theta, okay, that theta represents the angle. The angle formed between the polar axis and what we call beret. The beret from the pole. Okay, from the pole. Alright. Which means okay, so back to here. Alright. Let's say I have a point. I have, let's say, one point here. Okay, that point here, I represent by point P, for example. Okay, so that point P, the location is what? In terms of the coordinates, remember it is in the form of r. R represent distance, theta represent angle. So my r here, okay, if I refer to this point, my r is actually at 3. Okay, it's a 3 units from the pole. 1, 2, 3. From the pole, 1, 2, 3. So it's 3 units from the pole. So it's 3 units from the pole. So it is 3 and then comma. Okay, in terms of angle, here I am on the ray. This is what we call a ray. Okay, the ray between polar axis, this is polar axis, and this is the ray. Okay, alright. So here this is the angle here, pi over 4. So that my coordinate is actually 3 pi over 4. Okay, so that point P is 3 pi over 4. So if I am here, so I'm talking about this point. Q. What is my coordinate for point Q? My coordinate, okay, how is actually from the pole? That is actually is 4 units from the pole. Okay, so either from here you can see 1, 2, 3, 4. Okay, from the pole 1, 2, 3, 4 units, or you can just see this circle. It has this 4 unit. Can also. So that means R is 4. And then what about angle? Angle is actually this ray has this angle pi over 2. Okay, angle can be represented by radian, or it can also be represented by degrees. So I pi over 2 or 90 degrees. There's one major difference. Okay, back to here. There's one major difference, okay, between rectangular coordinate and polar coordinate. Like just now, rectangular coordinate, as I mentioned, if we are talking about this number, okay, this number minus 2, 3, when you plot, this is the location. Okay, that is the location for your minus 2, 3. That is the only location which has this coordinate minus 2, 3. But when it comes coordinates, okay, when it comes to polar coordinate, okay, for example, like this one, or even like this P, all right, whether it's P or Q or other coordinates, this location here, all right, you have this coordinate 3 pi over 4, not the only coordinate that is represented by this location. Okay, similar to here also, this coordinate here, this location, 4 pi over 2 is not the only coordinate that represent this location. Alright, you also have other coordinates that represent this location. Okay, how do you find other coordinate that represented by this location? Okay, if you go like another one round of a circle, you can go one, remember circle? Okay, angle, you can go more than 1 revolution. You can go 2 revolution. You can go 3 revolution, and so on. So you can actually come up to the same location here. So which means one coordinate, alright, is 3 pi over 4 or 345 degrees. Another coordinate that you can write is, if you go another one, you plus one more rotation. That means 45 degrees plus 360. 405. So that means another coordinate here is also 405, which also the same thing. And not only that, you can go 2 rounds. You can go 2 rounds, or 3 rounds, or 4 rounds, 5, 6, and so on, etc. Okay? Or you can also go clockwise direction. That means clockwise direction will give us negative angle. Alright? We can get, that means if it's a negative angle, so you are going this way. Okay? You are going that way. Okay? Alright? So that means for coordinate for that particular location on polar grid, okay, it is can be represented by infinitely many coordinates. For one location, okay, on polar grid can be represented by infinitely many coordinates. So that is actually is one major difference between polar coordinates and rectangular coordinate system. Okay, so it can actually rather confusing. Okay, in terms of if let's say we talk about like one location and then we ask you what is the coordinate for this, so people can give us a variety of answer. All right, because that one location can be represented by many or infinitely many coordinates. Okay, so I hope you understand. All right, but this is we won't test you in terms of like this one, because basically this is just introduction of polar coordinate. We are going to talk about complex number actually in coordinates in polar coordinates. So this is just for introduction only in terms of what we call uh, polar coordinate system or polar grid. Okay, all right. Now it's already 3 o'clock. Perhaps we can take 5 minutes break, and then after that I will continue. Okay, with this polar coordinate. All right. Okay. So we take 5, everyone. All right. Okay. So 5 minutes break. Okay, can you all hear me?
Yes, madam.
Yes, madam.
All right. Okay, thank you. Okay, let us continue. Okay, back to our polar coordinate. Okay, just to show you how do we actually plot. If let's say we ask you to plot polar coordinates without polar grid. This is polar grid. If you are given polar grid, it's easy to plot. Okay, but what if you don't have a polar grid? Let's say you just want to plot polar coordinate, okay, on your paper. Okay, similarly to our rectangular coordinate also. Okay, if you don't have a rectangular coordinate, of course you are not given a graph paper. Okay, when you want to plot your for example, you want to plot -1, -3, for example, on your XY coordinate axis. So what you do, you just on your paper, okay, you just draw your axis X and Y, okay, and then you know that -1, 3 means from the center. So you go 1 unit to the left and then you go down 3. So you just roughly sketch this is your -1, -3. Okay, all right, so it's just like a rough sketch only. Okay, so similarly, if let's say you are asked to let's say you want to plot your polar coordinate. How do you plot your polar coordinate? Okay, so I'm going to just erase this. Okay, I need space. If let's say we want to plot plot r theta, so let's say plot 2 and then 30 degrees. Okay, so it's understood. 30 degrees means it's a point. So plot 30 degrees means it's plotting for polar coordinate because you have angle there. Okay, so for polar coordinate, when you want to plot, what you do, you just starts from the pole. Okay, pole is a center, and then draw your polar axis. Polar axis is a straight horizontal line like your positive x-axis. Okay, you identify angle first. Okay, for polar coordinate, if you want to plot on our paper, we just need to identify our angle first. So assuming that 30 degrees is somewhere like this, that is 30 degrees. Okay, this is 30 degrees, like that. Okay, and then from the pole, okay, from the pole, you just need to measure like 2 unit distance. So you just need to make sure that it is whatever measurement you use is actually is the same. So it's this is just a rough sketch. It doesn't have to be exact. No need to like get a ruler and measure like 1 centimeter for 1 unit. You don't have to do that. Okay, just to be consistent, from the pole here, just measure 2 unit. Let's say assuming this is 1, this is 2. Okay, so that is your 230 degrees. Just like that. Okay, or let's say plot let's say 3 90 degrees. Okay, so this is straightforward, but you always start from the polar axis. Okay, all right, again starts from the pole and then draw polar axis and then 90 degrees straight going up. So this is your 90 degrees. Identify your angle first and then just measure 3 units from the pole, assuming like 1, 2, 3. So that's the coordinate of 390 degrees. Okay. So if let's say you have a negative r, if it's a negative r, how do we plot this? Okay, this is just for your information because you're not going to ask to plot this, but this is just for your information so that you understand. Let's say you have something like -2, then let's say 45 degrees, for example. Okay, -2, 45 degrees. Okay, this is for your information. How do we plot if r is negative number? R is negative. Always starts from the pole and then draw polar axis. Identify angle 45 degrees. So assuming that this is 45 degrees. Okay, if you go like from the pole going 1, 2 like that, that is positive r. That is positive 2. Okay, if you are going like from the pole 1, 2, that direction, so that is positive 2. So if it's negative 2, you have to actually go to the opposite 1, 2 like that, which means you got to like somehow like extend your line opposite. So opposite direction. This is what it means. It's opposite direction. It's a straight line. It's a straight line, but it's in the opposite direction. So then from the pole, measure 1, 2. So basically, all right, 1, 2. So that is the location for -2, 45 degrees. Okay, that's how we plot. Okay, all right. Okay, and mind you that this is actually not the only coordinate. All right, this is not the only coordinate for this particular location. So you can also have another coordinate which is similar. If you go this way, then you can also get another coordinate which actually represented by this coordinate. Okay, all right, this location. Okay, so this is just for your information. Okay, but what is important now is that, all right, once you have understood in terms of your r theta, okay, r theta. So r theta basically is the variable, all right, or parameter for polar. XY is the parameter for rectangular, okay, rectangular coordinate. So whenever we talk about XY, you know it's a rectangular. If we talk about r theta is the distance from the pole. R is the distance from the pole. Okay, we are talking about theta angle. So r theta, you know that is polar. Okay, that is one, that the most important. Okay, number 2 is that there is actually a relationship that we can form between polar and rectangular coordinates. So this is actually the important parts. Okay, so the important parts actually starts here. Okay, how do we actually find out the relationship between polar and rectangular? Okay, so basically it is also from the understanding, okay, from the understanding of a rectangular coordinate axis. Okay, so if let's say I draw the xy axis, all right. So if let's say I talk about like one point here in rectangular coordinate, which is our xy, that one point there can be represented by xy, okay, xy coordinate, okay. What do we mean? Okay, what does it mean by this xy coordinate? Okay, so it's understood. Xy coordinate means represent what? From the center here, from the center, okay, basically from the center, the coordinate xy represent a distance of 8x unit, okay, as well as y unit up, like this, right? Okay, so you have a distance of x this way, and then a distance of y going that way. So in other words, if I can form a right angle triangle, okay, in the first quadrant here, so that means I can form this okay, this right angle triangle. Okay, I want to draw a right angle triangle. So this is a right angle triangle that I can draw. Okay, all right. So that means this is actually x unit distance, and this is y unit distance, or x unit length and y unit length. That is my rectangular coordinate on my rectangular coordinate system. So if I now map this, I map this drawing on the polar grid. Okay, on the polar grid. If I map this on my polar grid, remember this now becomes pole. Okay, so earlier is the origin. Okay, if it's a rectangle, it's origin. So if it is a polar, all right, it's a polar coordinate, so that is a pole. Okay, and for this one, on my this point here, the xy also on the polar grid, it is represented by r theta. And of course, this is actually our polar axis. Okay, so if I map this, all right, rectangular onto the polar grid, so what I have is actually the point xy is the same as point r theta, in which then, where is the r? R is actually the distance. It's a distance from the pole to that point. So that is r. And what is theta? Theta is this angle here that is formed by polar axis to the ray. Okay, all right. Theta is formed by polar axis to this ray. All right. Okay. So if you look at this diagram now, the diagram, the right angle triangle diagram. Okay, if you look at this right angle triangle diagram, in which this is x, this is y, this is r, and this is theta. So you can actually find relationship between, all right, between x, y, r, theta, which means if you want to find relationship between polar coordinates and rectangular coordinate system, we are going to actually look it from here. We will try to define the relationship from this right angle triangle here. Okay, so if let's say, all right, I want to find my x, I want to define, okay, I want to define my x, all right, I want to define my x in terms of r theta. If I want to define my x in terms of r and theta, okay, it means that I am going to look at x here, x, okay, ignore the y first, don't look at the y, look at the x, look at the r and theta. Okay. All right. Okasha, can you hear me? Okasha,
Madam nak
raise
tanya,
your hand. Yes. Okay.
R equals square root x square tambah y
Okay.
square kan?
I haven't
Oh,
come
belum lagi. Okay.
to this yet. I am now explaining this.
Okay. Sebab
Not yet.
nak
Not yet.
tanya
Wait first.
R tu kenapa tak
Okay.
square?
Okay. That's why you wait first.
Okay. Sorry.
I haven't come to that one yet. Okay.
Alright. Sorry.
All right. Okay. I want to now I want to define x in terms of r and theta first. Okay. I want to define my x in terms of polar. Okay. I want to express my x. X is my rectangular. So I want to express in terms of polar first. So that means I'm looking at x, r, and theta. Okay. Forget about y. Don't look at the y. You just look at x, r, and theta from this right angle triangle. Okay. So if this is angle, remember in a right angle triangle, this is our adjacent, this is our hypotenuse. Okay. This is our adjacent, this is our hypotenuse, this is our angle. So we can have our trigonometric ratio here that we can define, isn't it? Between our x, r, and theta. So what is that? Between x, r, and theta, x is our adjacent. Isn't that we can define this as our cosine theta equals to x over r, right? Okay, cosine theta equals to x over r. So therefore, therefore, in our x in terms of r cos theta. Okay, if you look at a relationship between y, r, and theta. Okay, so if you look at the relationship between y, r, and theta, so this is our opposite, this is our hypotenuse, this is angle theta. So we can define this as sine theta equals to opposite over hypotenuse. That means sine theta equals to opposite over hypotenuse. So then from here, we get another definition for y in terms of r sine theta. Okay. All right. So from here, we got two relationship. Okay, between x and polar, rectangular and polar, rectangular x. This is polar. Or we can have another relationship for y. We can define y in terms of polar, r sine theta. Okay. What about if now I want to express my polar, I want to define my polar in terms of rectangular. So in this case now, still the same diagram, but now look at in terms of, let's say I want to express my r in terms of rectangular. So that means forget about theta, look at r, y, and x from right angle triangle. So isn't that r, x, and y, x, y, r, these are just length of right angle triangle. Okay, and remember there is one famous theorem when it comes to the length of a right angle triangle, by the famous theorem of your Pythagoras theorem, alright, that you can express as r squared equals to x squared plus y squared. Okay, this is from the Pythagoras theorem. So then only you can express your r in terms of square root of x squared plus y squared. Okay, Kasha, now this is your part just now. All right, so when we want to find r, we don't want to find r squared, we want to find r. So that's why we are using this formula. We want to find r, not the r squared. But we got this formula from our Pythagoras theorem It is the relationship between all the three sides or three lengths of the right angle triangle. Okay, and similarly, in terms of angle also, if you want to express or define in terms of our x and y, so you just look at your x and y here and angle theta. This is your adjacent, this is your opposite, this is angle. So you have a trigonometric ratio in which tangent theta is y over x. Okay, so you have your tangent theta is y over x, opposite over adjacent. So therefore, you can find your theta as tangent inverse y over x. So you have another formula here. Okay, so basically these are the formulas that you need in order for you to actually later on convert. Given, maybe you are given rectangular coordinate, question may ask you to find polar coordinate with respect to that particular rectangular coordinate, or vice versa. You are given polar coordinate and you are to convert, okay, to rectangular. So that means you need all this. You need all this. And in fact, these are the four important formulas that we will be using this a lot, all right, for the rest of the chapter. So for the rest of the chapter, for this complex number, you will be using this a lot. Okay, you'll be using this a lot. So that means it is actually, it's good if you can memorize by heart. Okay, it's good that if you can memorize this by heart. All right, or else if you do not want to memorize, that means you can just get it from this triangle. Okay, sometimes certain things you don't need to memorize. You can actually get it from your understanding of this relationship, from this right angle triangle between your rectangular and polar. Okay, but if you can memorize by heart, then that is even better, because you are going to use this a lot. Okay, because the rest of the chapter later on, the rest of the topic in this chapter is all about complex number in polar. Okay, in polar coordinates. Okay, so you will be using a lot. You'll be dealing a lot complex number in polar coordinates, and then there'll be like a section where you have to like interchange, okay, from polar to rectangular, rectangular to polar, okay, when it comes to complex number. So you are using this actually a lot. Okay, all right, let's look at some of the question here. Okay, where we are going to actually use that what we call the conversion formulas. Okay, conversion formulas, or the relationship. Okay, the formulas for relations between polar and rectangular coordinate system. Okay, let's look at this question now. Okay, all right. Okay, I hope you all are ready with this question. Okay, find the rectangular coordinates of the points with the following polar coordinates. So if you look at this coordinate given here, you have pi over 3, 3 pi over 2. So that is actually your angle in radian. Okay, so angle you can always interchange. It doesn't matter whether it's degrees or radian. Okay, so that is not a problem for this question. Okay, so let's do the first one. Let's do the first one. Okay, so for A, you are given 2, 3 pi over 2. Now, whenever you are dealing with polar coordinates or even rectangular coordinates, and then question asks you to change, okay, from polar to rectangular or rectangular to polar, it is suggested that you identify that particular point, all right, or another word, you plot. Okay, it is good if you can plot the point so that you have good idea later on, all right, when it comes to another different coordinate system. Okay, so that you know where does your point lies, okay, in which quadrant. Basically it's like that. Okay, now let's say we plot, okay, because it's good to plot because we need to plot sometimes, all right, in order for us to actually get the right answer. So if let's say you want to plot this 2, 3 pi over 2, okay, remember 3 pi over 2 is what? 3 pi over 2 is 270 degrees, right? So if you were to plot, okay, basically, you are going to plot like this, all right? This is a polar axis, remember? Because this is a polar coordinate, starts from the pole, polar axis, and then 3 pi over 2 basically is a straight line going down. This is your, right? This is your 3 pi over 2, or you can say 270 degrees. Okay, and then from the pole, just measure 2 unit, assuming this is 1, 2. So you have that. This is the point there. This is the point 2, 3 pi over 2. Okay, now if let's say I haven't computed yet using the conversion formulas, but logically, if you were to map this, you map this diagram here, okay, you map this diagram on the rectangular coordinate system, okay, on the rectangular coordinate system, you map this diagram on the rectangular coordinate system. Remember, this is a pole, so the pole is the same as your origin. This polar axis is the same as your positive x-axis. What do you think this point is in terms of rectangular coordinate? What is the location there? What is the coordinate, rectangular coordinate there at this location? From the pole, all right, go down straight. This is a straight vertical line going down. 2 unit distance from the center, go down 2 unit. So what do you think of that coordinate in terms of rectangular coordinate? Anyone?
Negative y.
Okay, so what is the rectangular coordinate for that particular location?
0, negative 2.
Yes, 0, negative 2, isn't it? So it's logic. 0, negative 2. Okay, 0, negative 2. If you map this diagram on your rectangular coordinate system, this is center, all right? This is vertical straight line going down, 2 units going down, so that is minus 2. So in terms of x is 0, y is negative 2, so coordinate for rectangular is 0, negative 2. That is logic. So when you use your formula, then you must get the same thing. If you don't get that, that means somewhere is wrong. Something is wrong in your calculation. Okay. So if let's say we compute this, okay, so that means we need to find x in terms, we are given this is r, this is theta. This is r, this is our theta. So that means to find the x, all right, we need this formula, that r cos theta. Which means r is 2, cosine theta is 3 pi over 2. Okay, so what is cosine 3 pi over 2? You can use calculator, all right, but I don't have a calculator with me. But I know that cosine 3 pi over 2, if I refer to the graph of cosine, remember last time, all right, 0, pi over 2, pi, and then this is 3 pi over 2, and then this is 2 pi. So that means from my graph of cosine, 3 pi over 2 is 0. So which means 0. That is my x. Okay, so what about my y? Y is r sine theta. R is 2. Sine is also 3 pi over 2. And again, sine 3 pi over 2. Okay, if I don't have a calculator, but I remember the sine function like that. 0, pi over 2, pi, and then 3 pi over 2, and then 2 pi. And this is minus 1 and 1. That is for sine. So which means if I refer to the graph, sine 3 pi over 2 is just minus 1. So isn't that is minus 2. Okay, so then I can conclude. Therefore, all right, my conclusion, All right, the rectangular coordinates of 2, 3 pi over 2 are 0, minus 2. So you got that 0, minus 2. Yeah, like what you said just now. Because it's logic, eh? So that's how we actually use formula, conversion formula. Okay, conversion formula, x equal r cosine theta, y equals r sine theta. Okay, can you all try B? See what did you get? B is minus 8 pi over 3. Minus 8 pi over 3. Can you try? Okay, can you all try and see what you get for the answer for B? Okay, anybody got the answer? All right, what's the answer for B? What's the answer for B? Anyone? Anybody got the answer?
-4, -7.
Negative 2,
Negative 4.
negative 7.
Negative 4,
Negative 4,
7.
negative 4, negative 7. Okay, let's see this. Okay. Now, first of all, okay, negative, negative, your answer negative, negative, that sounds right. Why? Because if we try to plot this, okay, if we try to plot this, so remember, this is your R is, in this case, this is R, that is theta. So if we were to plot this, that means we are using this from the pole, go polar axis, remember? And then we say we measure pi over 3. Okay, or maybe this is, it doesn't sound pi over 3 like that. Pi over 3 is 60 degrees, isn't it? So assuming this is again polar axis. So assuming this is pi over 3 or over 60 degrees. Okay, and then with the negative R means you go this way. You go that way. So from the pole, so you measure 8 units from the pole, 1, 2, 3, 4, 5, 6, 7, 8, something like that. So that's the point there. Okay. What we are trying to find out is actually if you map this if you map this diagram on your rectangular coordinate system, okay, you map this on your rectangular coordinate system, that means, okay, you will have like, for example, you have like this. So you have this is x, this is y. So which means the point here lies in the third quadrant on our rectangular coordinate system. So when this point lies on our third quadrant, that means we know that our coordinate will have negative, negative. Okay? So that's why just now you mentioned negative, negative. That sounds right because it's in the third quadrant. Okay, whether it's negative 4, negative 7, okay, then let's find out. Okay, from the calculation. So you are using again your x equal to r cosine theta for x. So you put your r as minus 8 here times cosine pi over 3. So, okay, you use your calculator. What is cosine pi over 3? Okay, cosine pi over 3, if we remember last time, cosine 60 degrees is half, isn't it? So this is where we got our minus 4. Okay, so x is correct, minus 4. Okay, what about y? So y is r sine theta. So again, minus 8 sine pi over 3. Okay, can you all compute this? Alright, I don't have a calculator. You can give us in terms of decimal, but if let's say I want to use exact value, if I want to use exact value, remember from here, last time we have our triangle 1, 2, 3. Okay, so sine pi over 3 or sine 60 degrees is from, if I refer from my triangle here, is 3 over 2. So that means my answer for y is minus 4 3. So I don't think that is a minus 7. Okay, so it should be a decimal number. It is not the 7. Unless you round, I do not know. Okay, I do not know. Can anyone compute this in terms of decimal? What's the number here? Minus 4 times square root of 3. What do you get? Unless you round. Okay, so perhaps maybe that's correct. Okay. All right. What is that in terms of decimal? Bashira, what is that in terms of decimal? Minus 4 times 3.
Negative 7. Kalau decimal negative
4 times
6.9.
6.9.
Yes.
9 something, isn't it?
Yes.
Okay. All right. Okay. So perhaps, you know, better not round lah. Maybe minus, give it in terms of decimal, because after all it's a number here with a 3. All right. So if you say like minus 7 is as though like it's an exact minus 4 minus 7 like that. Okay. So give in terms of decimal, or maybe you can just use exact value. So that would be better. Okay, Bashira.
Okay, madam.
So therefore, then you can conclude. All right. So therefore, you can conclude the same conclusion here, that the rectangular coordinate, okay, the rectangular coordinates of minus 8 pi over 3 is now minus 4 sec 3, or you can say minus 4 and then minus 6.9. Okay, you better use decimal. Okay, don't round to the whole number. Okay, this is from polar to rectangular coordinates. Okay, this is from polar to rectangular coordinate. Okay, let's try rectangular to polar now. Let's look at in terms of given rectangular now. You are given rectangular coordinates. Now you got to change to polar coordinates. So find the polar coordinates of the points with the following rectangular coordinates. Okay, so this time, okay, you are given xy. So you got to change in terms of r theta. Okay, let's do the first one, minus 2 sec 3 and then 2. So which means this is the x, this is the y. So now you want to change to r theta. This is what you want. Okay? So that means in the calculation, you need to use now this formula. Okay, this relationship. That r equals to square root of x squared plus y squared, and theta equals to tangent inverse y over x. Now, if you straight away, let's say you straight compute that formula, straight away compute r equals to square root of x squared plus y squared. Okay, so then minus 2 3 squared plus 2 squared. Okay, you can use calculator, but if I compute this, so this one minus 2 3 squared, that means 4 times 3 12, 12 plus 4, all right, 16. So square root of 16, so square root of 16 is 4. So I got my r. Okay, so definitely r will be in this case, all right, if you have like this square root x squared plus y squared, okay, definitely it will be a positive number. Okay, so r is 4. R is just a distance from the pole to the point. Okay, so that is our r. Okay, what if we straight away compute theta? What will happen? We'll see. Okay, tangent inverse y over x. So your y is 2 and your x is minus 2 sec 3. That means you are going to compute for minus 1 over sec 3. Okay, can someone gives me the answer from the calculator? What's the answer from the calculator?
Negative 30.
Negative 30. This is the
30.
answer from, okay, 30 degrees, right? Okay, this is the answer from the calculator. Straight away you get negative 30 degrees. Why you got negative 30 degrees? Okay, remember tangent inverse? Remember when we did tangent inverse last time? Okay, recall in chapter 2 when we did our inverse tangent. By definition, the restricted domain. The restricted domain for inverse tangent is from pi over 2 and negative pi over 2. Okay, that is the restricted domain, okay, for tangent inverse. Minus pi over 2 to pi over 2. That means the restricted domain for tangent inverse is only for quadrant 1 and quadrant 4. Which means if you were to use calculator to compute for inverse tangent, okay, inverse tangent, if this value here is negative, calculator will give you answer angle in quadrant 4. This is angle in quadrant 4, minus 30 degrees. That is angle in quadrant 4. Okay, it's angle in quadrant 4, minus 30 degrees like that. Okay, if this value here is positive, if you find your inverse tangent of a positive value, calculator will give you quadrant 1 angle. Okay, because last time if you recall, I mentioned calculator follow the restricted domain. Okay, right? So restricted domain for tangent inverse is either in quadrant 1 or quadrant 4, depending on whether this is positive or negative value. So for this question, because this is now negative, because of negative, that's why calculator straight away give you quadrant 4 angle. However, whether this is a correct angle or not, this is when you got to identify this coordinate here lies in which quadrant. Okay, this coordinate lies in which quadrant? So minus 2 sec 3, 2. This is minus x, this is positive y. This is actually lies in which quadrant? This coordinate lies in Which quadrant? That coordinate lies in which quadrant?
Second.
Quadrant?
2.
Quadrant 2. Yes, correct. Quadrant 2, isn't it? Minus 2, set 3, and then positive 2 for y. Negative for x, positive for y. That means that coordinate, if you were to locate, that point lies in quadrant 2. So the point lies in quadrant 2. Okay, somewhere in quadrant 2, let's say this is the point, minus 2, set 3, 2. And the calculator gives you this negative 30. So that angle, that minus 30 degrees, is not the right angle. It's not the right answer for theta. Okay, because this 30 degrees is angle in quadrant 4. So you need to find angle in quadrant 2. So what you need to do is actually basically you use your concept of reference angle. This is 30 degrees. Okay, so which means the right angle is the angle lies in quadrant 2, which is your 150 degrees. So this is the right angle. Okay, so that means you can say now, okay, either you can actually write, if you want, the point. If I want to write conclusion longer, I will write like I just explained the point, minus 2, set 3, 2 is on quadrant 2, thus, all right, in quadrant 2, angle is, etc., etc. So we can write in a longer conclusion, or you can just refer from here. You know that because this is quadrant 4, and from the question here, this coordinate lies in quadrant 2, hence you know you must find your quadrant 2 angle. So straight away, once you have found your right angle, you can straight away just conclude like just now. Okay, that the polar coordinates, okay, of just now is what? Minus 2, set 3, 2. You can just straight away say 450 degrees. Okay, so you can just state like that. Okay, and mind you that again, as I mentioned earlier, polar coordinate has infinitely many coordinates which represented at that particular location. So perhaps I give you this type of coordinate from the calculation here. I give you 450. But if let's say there's another person wants to give a different coordinate, it's still okay. We will accept, because remember I mentioned polar coordinate has infinitely many. 150 is where I go this way, counter clockwise. I'm using positive angle. I can also, all right, or other people can also give us in terms of, for example, this type of angle can also, the negative angle. Okay, can also. What is that? That is what? Negative to 10, isn't it? Can also. So you can also say for negative to 10. Can also. Still correct. And not only that, people can add another one more round, 150 degrees plus 360. Can also. So actually, basically, it's infinitely many representation or many coordinates for polar. But normally, what we normally do or what we usually do is we just give in terms of whatever that we got from our calculation, the first time calculation, and then we just check. Okay, if this is quadrant 4, our point lies in quadrant 2, we just find straight away this one particular angle. So no need to make it like so complicated. 150 plus another 360, no need. Or you want to go this way, also no need. Okay, right? Okay, can you all, okay, what time is it now? It's, okay, 4 o'clock. Okay, maybe one last one. Can you all try quickly this one. B, 2 minus 2. Okay, try B, this coordinate now. 2 minus 2. Okay, 2 minus 2. Okay, what's R? What is R?
-2.
-2? R, sure?
Zero.
Use your square root of
Square root 8.
use your square root of x squared plus y squared. Yeah, square root of 8.
8.
Okay, square root of 8. You use your formula. Use this formula for R. Square root of x squared plus y squared, and then use the formula for theta is tangent inverse y over x. So it should be square root of 8, or you can say 2 square root of 2. Okay, what about theta? Or what is the correct theta? So theta, you need to see your coordinate lies in which quadrant?
-45.
Okay, 2 minus, okay, -45. 2 minus 2 lies in which quadrant?
Quadrant 4.
Coordinate 2 minus 2. Yes, 2 minus 2 lies in quadrant 4. So straight away for this particular question, calculator definitely will give you -4 because, calculator will definitely give you quadrant angle in quadrant 4 because the value is negative, isn't it? So that's why they give you -pi/4 or -45 degrees, right? Okay, so that means for B, okay, B is just now is 2 minus 2. All right. So 2 minus 2, this is x, this is y. Okay, this is our x, this is our y. So if we try to plot, definitely the point is somewhere here. 2 minus 2. So it's in quadrant 4. All right. Okay, so R is straightforward. So straightforward. Okay, so that means this is square root of 8, or you can write as in terms of like this also can. Okay, and then theta, tangent inverse y over x. So tangent inverse, okay, -2 over 2. Another word, tangent inverse -1. So calculator will give you straight away -pi/4 or -45 degrees. Okay, do you want to change -45 degrees? Up to you. After all, -pi/4 is like that. Okay, so -pi/4 or -45 degrees is already in quadrant 4. Coordinate also in quadrant 4. So therefore, you can leave your answer in terms of -pi/4 also can. So you don't have to change. But if you want to change to positive angle, can also. So up to you. Okay, so therefore, you can say that the polar, okay, polar coordinates of 2 minus 2 are 2 square root of 2 or square root of 8 and then -45 degrees or -pi/4 can, or if you want in terms of positive, what is positive angle here?
25.
What is the positive? Yes, positive angle is 315. So you can say up to you. Also can. Okay, acceptable. So if you leave your answer in terms of minus 45 degrees, also acceptable. Still correct. As long as angle in quadrant 4. Okay? Alright, is it understood, everyone? So I think our session today ends here. So the rest we will continue next week. Alright? Any question before we end the session? Can you all understand? Is it understood?
Yes, madam.
Yes, madam.
Yes, madam. Understood, madam.
Yes, madam.
Okay, good. Alright,
Yes,
very
madam,
good.
understood.
Okay. Alright. Okay, good. Okay, so I think we can end the session now. Okay, but before that, again, just to remind you on Thursday, Thursday tutorial. Okay, tutorial session on Thursday. Those I've assigned questions, so I hope to receive your solution. Perhaps maybe tomorrow. Okay, tomorrow afternoon. Okay, tomorrow afternoon. And send me the photos, in photos image, image photo. Don't give me the PDF because I'm going to share in my iPad. So I don't want to use PDF because if PDF I cannot